Hi, this is Clarice from Undergraduate Group Number 1 of Software Engineering Project. Today I will present a code review of our Lunar Rover robot project. The code of the system consists of two major components, the EV3 program and the PC Lunar Rover. Our group implemented the functions of the system completely and correctly based on our design document. The code adheres to the normal convention. Although the code is done by the individuals, we attempt to make the structure of the code complete and tidy as much as possible, and the code style and format, for example, like the indentations of the code, is uniform and consistent. We comment precisely when we wrote the code to make the code easy to read and debug. We condense those repeated codes and make sure that there are not any needless or uncalled procedures or any unreachable code existed in the system to make the code structure clear. The code of the system is testable, and we have the individual test files to make sure that we will be able to test each method. Besides, in order to make the modulus not too complicated, we don't have a lot of hiding dependencies between the class. To ensure the consistency of the code, all the variables that we have in the system are well defined, and we do not have any meaningless or unused variables. The variables have clear names and defined in appropriate types of consistency or projection, and they are all in correct range. The minimum requirement of the storage and memory, as we mentioned in section 7 of our SDD document before, of the computer is 1 GB. The data format that we used and we import is XML. Each statement operates the correct data they need. The system can allocate the memory correctly. We implement that the system will use the storage efficiently as much as we can. The imported map file and the input arguments will be tested for their validity and completeness first. The system will be able to print out the return value, including the value of error return. When the timeout or error traps happen, the system will be capable to aware. Before the system tries to access the file, it will check the existence of them first. When the program terminated, the system will print out closing time and the files and devices will be in their right states. The system input or output mechanisms are always used to inform the user. For example, the current state of the robot, the current status of the program, the current status of the connection between the PC and the robot, the annual return value, and so on. The input values will be checked before it is used. Based on the different error, the program will give different process method followed by the standard use of error handling task. The code does pay attention to those hardware faults and error device recovery. The system does not have any redundant code or stubs, and we move all the test routine into single files, which will be deleted once the project is completed. We soft code the constant and the literals to make sure it is easy to change and debug. The indexes, pointers, and subscripts we used are checked against the array, the record, and the file bounds. Moreover, we fully nested the loops, the branches, and the logic constructs. This is all today. Thank you for watching this video. See you next time.